learners. Welcome to today's technical mathematics lesson. My name is Moses Maudu. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Today we're going to be looking at analytical geometry part 2. So part 2 meaning that we're going to be looking at the grade 12 analytical geometry. And analytical geometry is one of the easiest topics in technical maths paper 2. It is in the first question. First question is the grade 11 analytical geometry, and the grade 12 analytical geometry is in question 2. So we're going to be dealing with question 2, and that question 2, the marks there in question 2 is plus minus 15 marks. So the 15, it might be 12, it might be 13, it might be 14 or 15. So please, let's go through this and see where can we get marks. What are the things that we need to understand in order for us to get marks in this question? What you must be able to do by the end of this lesson, you must be able to determine the equation of the second in the form x squared plus y squared equals to r squared. Remember, we're preparing you for the prelim examination and also preparing you for the final examination, so that then you understand how do we get the equation of the second if I'm given that type of question. Obviously, you'll be given 1 point to get to that. So you know with a point you have got an x and a y. So in other words, that's what we're going to be doing, substituting the value of x and substituting the value of y to get the value of r squared there, which is the radius squared. We must be able to determine the equation of the tangent. What is a tangent? It's that straight line. So if it's a straight line, it must be connected to the equation of the straight line. So the equation of the straight line, y equals to mx plus c, we must be able to get the equation of the tangent. To get this type of questions where they say, determine the equation of the tangent, we must also be able to do it. Sketch the graph of an ellipse given the equation in this form. So remember, the ellipse will be given in that form: x squared over a squared plus y squared over b squared equals to 1. Whereby you have to understand how to get the a squared and the b squared. Given maybe 2 or 4 or a number there, you must be able to get the value of a, which will be related to the x on the sketch. But now let's look at the basic formula for analytical geometry. Now look at this. These are the formula that you will get in the formula sheet. You don't need to memorize this formula, but you must just know where this formula is. So if you've got a formula sheet in front of you, I want you to do this, to say, this is the distance formula, and it is indicated by that. So if you go to your formula sheet, you'll realize that the formula is written like that, but that they did not write down what that formula is. So you need to go there and say, but this formula is d, so it is distance. And there is no difference between the distance and finding the length, because in exam we see examiners will say, determine the length of a line AB, and the other questions can be determine the distance between A and B. So if you get these two types of questions, you know that distance and length will be the same thing that they're looking for. So I can be able to get the distance by using that formula. So that formula is x2 minus x1 and y2 minus y1. Please, sometimes when you're subtracting, actually when you're subtracting, you're not supposed to swap the values. For instance, if I say x1 minus x2, this side I must also say y1 minus y2. Because remember, with subtraction, if I've got 2 minus 3, it is not the same as 3 minus 2. So if I swap this one, I must also swap this other one. But please, in an exam, please do not try things that you have not tried before. Let's go for this formula that we are having here. which is in the formula sheet, and do it as it is. The next formula is the midpoint formula, which is also a problem with the learners. I mean, the formula is a plus, and when you go to your book, I don't know what your pen do, but in your book, you write x1 minus x2. And that formula is incorrect. It's a plus. So copy it as it is. So you write down x1 plus x2 over 2 and y1 plus y2 over 2. The gradient formula, you see the m there for the gradient and the m for the midpoint, because this is a point. So we write the point as a capital letter, it's a point with a capital letter A. So the m there is the capital letter for the point that we're looking for. In this case, it's m. So sometimes you might find the coordinates of A, which is the midpoint of line BC, for instance. The small letter m represents the gradient. So this you have to also to know. And the gradient also, you must copy it correctly. Here's the misconception, whereby you guys write x2 minus x1 over y2 minus y1. I don't know where you get this formula, because the formula illustrates this. It is the change in y over the change in x. So it is not the change in x over the change in y. So please, let's make sure that this formula, we practice them and we know where to use them. Please do not memorize them, just practice them, just know which one to use where. So if you take a question paper, for instance, past paper, and you have those questions in your question paper, then if it says determine the distance, then you just write in next to it, you just write the formula for distance. That's how you can practice the correct formula. And if they say calculate the midpoint, you just take the midpoint formula and put it just next there. Because there you get marks for writing down those formula. Gradient formula, if they say calculate the gradient between the two lines, you take that formula, then you plug it in there. Then in that way you practice. And then the next thing that you're going to be doing is to check which distance are we looking for. Between A and B, between P and Q, then you take those coordinates at P, coordinates at Q, plug them into your formula. Then you use a calculator, you get to the answer. All right. Now the midpoint formula, same thing. So once you have done that, you just plug them in, and then from there you check between which 2 points are looking for the midpoint, and then from there you just plug in the values, and then you get full marks for that. Use a calculator after that, then you get full marks for it. The next one is the inclination, and I know you have done all these things last week. I'm just recapping on what you have done, but also putting some extra meat on what you're supposed to do in the exam. Now the ellipse, this is what we're going to do today, and also the circles, this is what we're going to do today. So with the ellipse, please make sure that you understand what that means, that a squared mean. You say, how am I going to get the x-intercept? Because remember, it's written as x squared. How am I going to get the x-intercept of this ellipse? How am I going to get the y-intercept of those ellipse if I'm given something like that? The equation of the circle, I've talked about it. If I'm given a point, x and y, I'm just going to plug them in here to get the r squared. But remember, if I'm given that point, I can get the equation of the line. So I mean the equation of the circle. It must be a circle. You must check the circle, then that formula must be. The one thing that we sometimes do not do is to write down the equation, because you are asked to determine the equation, and at the end we don't write that equation. Please make sure that we also understand. The inclination is very, very important. You might be given a circle with a line, and then you are requested to get the inclination. You must know that an inclination is nothing else but the angle, and that angle is an angle between the x-axis and the line. So if I've got a theta here and I've got a line, and if I've got if I draw it, for instance, if I draw a circle like that, and I need that angle here, so what do I do first? I must get the gradient of that line. Once I get the gradient, I'm going to input my gradient on here for me to get the angle of theta. So remember, it shifts tan of that gradient to get to the value. Okay. In the next slide there, we have the activities now. Now let's look at the activities. Please do them with me. Let's read that. In the diagram below, O is the center of the circle, right? So it means it's the center. So we know if I've got a center, a line from the center to the circumference is called a radius. So in this case, I don't have any radius. And it is defined by the lovely, I love this question because now the equation of the circle is already been given. So I have the equation of the circle, I don't have a problem. I have the radius squared as 40. It says A and B are points on the circle such that this line here, the equation of that line is given as y equals to minus x plus 4. Already I know that that point here will be a 4. It's a y-intercept of the graph. Right. But my problem here, I know that this is going to be 0 and 4. My problem is to get the coordinates of that. But let's see if I can be able to get it. What is the name given to the line passing through A and B? Here's a line passing through A and B. It is touching the circle at 2 points. So if it's touching the circle at 2 points, what do we call this line? I know when it is touching the circle at 1 point, for instance, in that case, if it touches the circle at 1 point at A, that line is called a tangent. But what do we call a line that touches the circle at 2 points? This line is called a secant. So a secant is a line that touches the circle at 2 points. Those 2 points, A and B, that line that touches there. So it doesn't pass through the center of the circle. Once it passes through the center of the circle and it doesn't go outside the circle, it doesn't go outside the circle, that line there, it will be called a diameter. Right? Right, so that line here, but this one that goes outside the circle and outside the circle, that line will be called a secant. Right. Okay, last question here. So the terminology is very important for you guys to understand. I've got a diameter, I've got a secant, and this terminology, we're still going to use it in other section of work in technical maths. Now, this question says, now let's calculate the coordinates of A and the coordinates of B. What do I know about coordinates of A and B? Those are called intersections. So these 2 points here are called intersections. So those are the points where the two graphs are meeting. So I've got two graphs here. I've got the graph of x squared plus y squared equals to 40. I've got another function of y equals to negative x plus 4. So I've got these two. Then it takes you back to paper 1. In paper 1, if I'm given two equations, what do I know? It's Martinez equation. So which means that I've got equation number 1, I've got equation number 2. So I know the equation 1 is the one which is simpler, it doesn't have squares and all that. Equation 2 will be the one with squares and multiplications and all that. Now, in this case, this equation here is already in the form y is equals to. So there's no problem with that equation. I love it when it's like that. Because I just need to take this part here and substitute it into the value of y. So I'm going to say x squared, but instead of writing y, I'm going to write negative x plus 4, that will be equals to 40. You see now, I don't have a y. So it's easy for me now to work with one variable. But once I work with two variables, it means that one must be replaced by that equation that I've formed now here. Now I'm going to multiply out. Remember, this is squared. Don't forget that. Now I'm going to multiply it out, the brackets. I'm now going to have x squared. Now, if I multiply the x and the minus x and the 4, I'll get minus 4x. Double that, I'm going to get a negative 8x. And then from the 4 squared will give me a 16. And that will be equals to 40. Let me take the 40 this side because I just want to have a quadratic equation. And x squared plus x squared is not x to the power 4, my boys and girls. So it is one of them plus one of them. So it is two of them. Right? We have minus 8x. Then we subtract this, something I'm going to get negative 24, which is equals to 0. Then in this case, I can see that 2 can divide in all this. I divide everything there by 2. Please do not forget to divide the 0 by 2 also. So it's x squared minus 4x minus 12 equals to 0. Then I factorize. Please, if you don't know how, if you are still struggling to factorize, this is not time to start practicing factorization of quadratic equations. Please, you go directly to the quadratic formula, which is in the formula sheet. So in this case, I think I can be able to factorize. Those who can, please help me out. So it will be x and x. I can see factors of 12 that can give me 4. It will be 6 and 2. So the 2 will be positive and the 6 will carry the sign of the middle term. Now, in this case, I'll have x equals to 6 or x equals to negative 2. So I've got two values of x. So meaning that in that coordinate, x in this case can be, which one can we take? 6 or minus 2? It's on the left-hand side, so it must be negative 2. At b, x is on the right-hand side of 0, so it can be 6. Then what do I need? I need the y values. How am I going to get the y values? I'll have y equals to negative x plus 4. Let me rewrite this. So I'll have, if I substitute x by 6, so I'm going to get negative 6 plus 4, which will be negative 2. But if I substitute x by minus 2, so I'll have negative into negative 2 plus 4, I'll get 2 plus 4, which is 6. So meaning that my coordinates of A, in this case, if I substitute by minus 2, I got a 6. So I'll be right. I think I'll be right because 6 will be somewhere there. Right? Then if I substitute by 6, it means that I'm going to get a negative 2. So which is the value. So my A coordinates will be negative 2 and 6. My B coordinates will be 6 and negative 2. Okay, this is just take you back to what we have done in grade in analytical geometry. I mean, sorry, in simultaneous question in paper 1. So must be able to link the work that we have done there and the work that we've done in paper 1 and paper 2. So that's a very simple and straightforward question. I don't think there is a problem. If you know your simultaneous equation, this is the easy equation. This is the easier of them all. At C, it says determine the equation of the tangent. Now you see, what do I know? Once they say equation of the tangent, I must just know that they want the formula y equals to mx plus c. They say it must be passing through A, so which means that I must just draw a picture here and say, oh, okay, my tangent is passing through A. But the A coordinates, I have them because I know it's minus 2 and 6. Those are the coordinates of A. Now it says it's the tangent. So what do I know? I know that in a tangent, I have a radius. I have a radius. And what do I know about the radius and the tangent? They are perpendicular to each other. So once they're perpendicular, what happens? The gradients, when we multiply the two gradients, we get a -1. So now I'm going to do this question like this. Now I'm going to say, first let me get the gradient of OA. What will be the gradient of OA? I want the gradient of O to A. The gradient of OA will be 0 minus 6 all over 0 minus into minus 2, which gives me a -6 over 2, and then that will give us -3. So the gradient of that line is -3. But now, how am I going to get the gradient of the other line? Remember, if I know the gradient of that line is -3, then the gradient of that line must not be a problem, because the gradient of tangent times the gradient of a radius must give me -1. So the easy way to do it will be to come here and say the gradient of the tangent. Can you see how I'm writing it? The gradient of the tangent, if this is -3 over 1, the gradient of the tangent, I just turn this thing upside down. So it becomes 1 over 3. If it's a negative, I write this one as a plus. Don't have to write plus. We know 1 over 3 and plus 1 over 3 is the same thing. So you don't have to write it. Now I've got the gradient of that line. What is the gradient of that line? The tangent, the gradient of the tangent is 1 over 3. So if I've got a gradient and a tangent, the gradient and a point, here's the point. Simple. So I'll go y minus y1. This formula is there in the formula sheet. X minus x1. All right, then I substitute. Then I'm going to call this point here, I'm going to call it x1, and that one I'm going to call it y1. So I'll say y minus, what is my y1? 6. What is my gradient? 1 over 3. What is my x1? -2. See? Then I multiply out and then transpose, I got the equation. So I've got y equals to 1 over 3x plus 2 over 3 and then plus 6. Because if I multiply this and that, negative and negative is positive, and then that will be 2 over 3. The -6 transposed is plus 6. If I add this 2, if you don't know how to add this 2, please use a calculator. Don't be like me. 1 over 3x. I know 3 times 2 is 18. 18 plus 2 is 20. And that will be 20 over 3. That is the equation of the straight line. Can you see it is in the form y equals to mx plus c. My c is this one, my gradient is that, the x is that. I'm able to can write it in that form, straight form. Okay, so you must understand this type of question. If the line does not touch at 2 points, it cannot be a tangent. If it touches at 2 points, it cannot be a tangent. So this line touches at 1 point, and because they say it must pass through point A, they didn't say it must pass through point A and B. This line can never be a tangent. So please make sure you understand the question and the sketch. Take what you have read and look at the sketch and see. That will make sense. Right. Now, lovely question here. So this question says, as a technical math student as you are, you being fascinated about how things are made and how you can apply your technical skills, your attention was drawn to a rugby ball. Remember, as artisans, we are fascinated about how things are made. We are fascinated about how a tool is made. Fascinated also about how a car is made. So then my attention is drawn to things that I'm fascinated about. Now, in this case, the rugby ball, as depicted in the picture below there. So now this examiner is trying to determine if you know the shape of that ball. So the shape of that ball is a rugby ball. It is a rugby ball, but what is the shape of the rugby ball? What is the shape of that rugby ball? So some might say, well, it's a sphere. Some might say, well, it's oval, it's an oval shape and all that. So we can. All right. So, but you cannot say it's round. Okay. So, either it's a sphere, we have if I cut it out, then I'll have a hemisphere and all that. As you are analyzing, I think the basic one there, I can just say this thing here, it's going to be an oval shape. I think oval will make more sense. Okay, right. As you were analyzing the shape of that, you came up with the equation. Obviously, it's people who are fascinated. You try to make sense of this thing that is in front of me. So what is in front of me is that rugby ball. I'm fascinated about the rugby ball. Then I come up with the equation to say, oh, okay, the equation of this thing will be that. Maybe I've measured it. Obviously, you have to measure and do all those things. So measured to x squared over 64 plus y squared over 16 is equals to 1. Now the examiner says, express this equation in this form. Oh, I've seen this form in the formula sheet. Now it means that instead of writing 64, the x squared is still there, it's fine. The y squared is still there, it's fine. But this one here must make a plane. There's 64 here. I must write it as a square. So what do? Go to my calculator. I press 60 square root and I put 64 in there. So once I have done that, how am I going to express this? So I'm going to say the x squared is still there. I must just replace that a squared. So I go 64. What is the square root of 64? The square root of 64 is 8. But it said it must be a squared, so it's squared. So 8 squared is 64. Can you see I'm going back there? So they just want us to write it in the form where the a must be a squared and the b must also be a squared. So then I'll say plus y squared is still there over. The square root of 16 is 4. So I'm going to write this 4 squared. The 1 is still there. And that's how I get my marks. Easy, straightforward. See, I'm not concentrating on measuring that ball and all that. I'm doing the mathematics behind the statement. Okay. All right. And obviously the next question will be sketch on the grid provided. A boys and girls will be given a grid, and that grid, some of the grids will be having numbers. Some of them will not have numbers. So if they don't have numbers, then make sure that your scale is correct. I cannot say this is 1, this is 2, this is 3, and all that. I must make sure that the scale is correct. So if the scale is correct, that's no problem. In this case here, I already know that 64 is 8 squared. 16 is 4 squared. So I go to my diagram. And then from there, on the x-axis, I look for 8. So I'll look for 8 on the x-axis. All right. On the y-axis, I'm going to look for 4. Right. What I've done on my left there, I'm going to go and look for my 8 there. I'm going to look for my 4 there. So in other words, on the y, I'm putting a 4. On the x, I'm putting an 8 because of this. And we know most of the time, the mistakes that are done by you guys, it's to take that 64 and try to put 64 on the x-axis. It cannot be 64 because it was a squared and it's x squared. So the square root of 64, it's 8. So that's what we put on the left and on the right. Then from there, I do not use a ruler. I just connect these points like that. Obviously, if the points are not written here, you must write the 8. There you must write -8. There you must write a 4. Oh, sorry. So that should be a 4, that should be a -4, that should be an 8, that should be a -8. Because when we mark your y-intercepts, we mark your x-intercepts and the shape, and that gives you 3 out of 3. This question, each and every one of you must get all the marks. It will always be there. So you cannot get a 0 on this paper. The ellipse, it's your 3 marks. In the exam, you can even start with an ellipse and go to the question paper and look for the ellipse and draw it and get it done with. Because your question paper will be in such a way that it's a question paper and an answer book on the same book, one book, question paper and answer book. So you're going to answer that. So you just page through, go to question 2.2, then you go and look at the ellipse, draw it. Then from there, you know you're done. You already have 3 marks. Gain confidence in getting to the other questions. Right. Now let's look at the other question, the next question. Now the next question here, it says in the diagram below, O is the center of the circle. I'll always say that. You'll always get it as O as the center of the circle. Now it says there's a point P here, square root of 5, and -5 square root of 5. Now the first question here says, determine the radius of the circle. Now, how am I going to get the radius of the circle? Remember, they want the radius. They don't need the radius squared. They need the radius. How am I going to get the radius of the circle? So the radius of the circle is from this point to that point, or from this point to that point. So meaning that that point here is on the circle, I can be able to get the radius of the circle. So my radius of the circle, I can go radius squared, it's equals to. Remember, radius squared is the same as getting the distance. So I can say 0 minus that x value squared and 0 minus that. But I know if I subtract a number from 0, I get that number. So the easier way for me will be to say square root of 5 squared plus -5 root 5 squared. Because it will be 0 minus that and 0 minus the other value. So I'll still get that value. So now, if I use my calculator, I'll get 130 minutes. This is r squared. But the question says you must get the radius, not radius squared. So therefore, I'll go and get my radius here. So my radius will be the square root of 130. Please, in analytical geometry, try to leave your answer in set form. I know in some questions they will just not say anything, but in analytical geometry, I know that sometimes they'll say leave your answer in set form, but in all the other questions in analytical geometry, just leave your answer in set form. Unless stated for it, no, you must write down your answer correct to a decimal. Then you can do that. So read what the instruction says. In the next one, it says you must get the coordinates of r. Let me see. R is here. I can see it's a symmetry. You see? Right? So that point here and that point here are the same. The only difference is the position. So in this case, the coordinates of R will be the same as the square root of 5 and 5 root 5. It will be the same. My issue here will be the position. The position here for X will be negative. So that should be negative. The position for Y here, it will be a positive value. So that will be positive. So that should be negative. The other one should be positive. We'll just solve that because it's a symmetry to that on a second. All right. Now that is the equation, the coordinates. And another thing that we need to know, coordinates are written as the value of X and the value of Y. So this must be in that order. We cannot say coordinate and you write X is equals to this and Y is equals to that. That is not a coordinate. So a coordinate, it's that pair of values. X equals to this and Y is equals to that is called a coordinate. Right. the next one, determine the equation of QS. QS. I know the coordinate of this, it's 5. It's negative root 5. And the other one is 5 root 5. That is the coordinate of R. Now, what is this line here? That line here, it's my tangent. So if that line is my tangent, I need to find the equation of QS. Now, this is what I'm going to do. I'm not going to use another formula. And please note this formula. Very, very important. I'm now going to use this formula. I already have the equation. I already have the radius squared. So I can use this formula. X times x1 plus y multiplied by y1 equals to r squared. I know some of the teachers are using it, and I know by now everyone loves this formula because it takes you directly to the equation. Okay, you don't have to get the gradient of this line and the gradient of the other line. You make mistakes with the gradients, then from there you mess up everything. So we're just going to use this point. We don't need the gradient of that. We just need a 1 point. So now let's substitute. My x1, I'm going to call this one x1, 1. So my x1, it's going to be negative square root of 5 plus y multiplied by my x2 is going to be 5 root 5. The whole thing must be equal to 130. Remember the equation of the circle was y squared equals to 130. So we take the r squared. We don't take the square root of 130 because the square root of 130 is the radius. Right. From there, I'll have negative square root 5 times x plus 5 root 5 times y equals to 130. I make y the subject of the formula. I'm not going to do everything there. We're just going to take this one to the right-hand side. Then it's going to give us positive square root of 5x divided by 5 root 5. Then we're going to have plus 130. Then we're going to also divide it by 5 root 5. So what I've done is I've taken this one here and divide everything. The minus becomes a positive on the right-hand side, and therefore my equation will be y equals to 1 over 5, because the square root and the square root of 5 fall off, plus 5 into 130 will give me 26 over square root of 5. But if you use a calculator on this one, it will not give you that. So in other words, the calculator is based on the rationalizing of the denominator, which I don't want to go there. And this answer will be perfect. But if you use a calculator there, you are going to get the 26 multiplied by the square root of 5 all over 5. So it is the same thing. So don't worry about it. The calculator will still give you the answer that is you get on the calculator. It still be okay, still be fine. Right. Write down the coordinates of S. S is there. So S, I know the equation of that line. What is the equation of that line? Is this one. S is the y-intercept. So in other words, the coordinate of S will be the y-intercept x is 0. The y value will be the c. It will be that value there. So that will be the value of c. Okay. I just love this question. This question is just very nice. But now, here's the trick here. You see here, they put the square root already. Want to trick you. Just a trick. If they put a square root already, I still need to put a square root on top of that square root. So in other words, what is the value here? So I'll say the square root of 9 is 3. Plus y squared over 16 equals to 1. You see? Now remember, I still need to put a square root, which means that my x values are going to be square root of 3 plus minus, and this one is square root of 16 plus minus. So the x values here will be the square root of 3, it's 1,73 somewhere. So it will be somewhere there. So I'm going to write square root of 3 negative. On the other side, I'm still going to put square root of 3 positive, yeah? Right. So my x values are square root of 3. You can see the trick, because the trick, you might say, no, the square root of 9 is 3, and then you come here, you put it at 3, and the x-intercepts are completely wrong. The square root of 16 is 4, so I'm going to go to 4 and to negative 4, right? So I've put these values in. Remember in your exam, these points are not going to be there. 1, 2, 3, 4, minus 1, 2, they won't be there. So you must make a plan there. You must make sure that your scale is correct, so that then you can have a beautiful looking ellipse like mine, right? So the ellipse there, minus 4 there. If the points are not written, please write them down. Square root of 3, negative square root of 3, 4, minus 4, so that you get your marks. Okay, that's a tricky one. Please note that. Okay, right. The next question, there is circle with center O on the origin. Below WTR, you see now you're told WTR is a tangent. All right? Now it says at point T minus 2 and 2, line PQ and QS, PQ and QS are other tangents to the circle at P, right? Right, so if they are tangents to the circle at P, this is a radius, so this angle is 90 degrees, right? This is a radius, this angle is 90 degrees, okay? Obviously on that line, angle there is 90 degrees, which means that that angle will also be 90 degrees. I'm just putting that just there. All right, so that we know. That angle, if I put that angle there, that angle will be 90 degrees. That radius there, so because it's a tangent also. I've got 3 tangents. Now, determine the equation of the circle in this form. So already the form is given, no problem. So what am I going to do? I'm now going to substitute the point that is on the circle. The only point that I have on the circle is T2 and minus 2. So I'm going to come here and substitute 2 squared plus negative 2 squared equals to r squared. Remember, r squared must always be calculated. So we've got a 4 plus a 4 equals to r squared. My r squared will be equals to 8. My equation now is x squared plus y squared equals to 8. That is my equation of the circle. So the equation of this whole circle, it's squared, x squared plus y squared equals to 8. Now they ask me this type of questions, 1 mark, 1 mark, 1 mark. So it means that I must just know how to get these points without working them out. Now, right? Now I know the equation of the circle, it's x squared plus y squared equals to r squared. Now they're asking me, how am I going to get the equation of, the coordinates of point P? No problem. The point P here, I know it's a radius. All right. So how am I going to write point P there? Now my point P is going to be negative 2 root and 0, because at this point the y value is 0. So here it's going to be negative 2 root 2. How do I know? Because the radius squared is 8. So radius squared is 8. The radius will be square root of 8. You punch this on a calculator and say equals to it will give you 2 root 2. So my radius here is 2 root 2. But the value at that point is minus 2 root 2. Q is a bit of a challenge here. Why am I saying it's a challenge? I know the x value, the x value there. The x value is going to be 2 root, negative 2 root 2. Because it is the same point here. All right? Now, I know the y value. The y value at this point here is also on a radius, but in this case, the positive one is 2 root 2. So which means that that point on the y value is going to be 2 root 2. Nice. Okay. Love these questions with coordinates. Very nice. The s, we already got it. What would that be? It will be 0 and 2 root 2. Because at s, the y value is 2 root 2, but the x value, it's 0. Okay. Now I know what the next question will be. What type of a parallelogram is P, Q, S, O? I love it. This is, we already said is 90. That we said is 90. That we said is 90. That one is obvious, it's 90. The distance from here to there, it's 2 root 2. Remember, now I'm talking distance, I'm not talking coordinates. The distance from here to there is 2 root 2. The distance from here to there is 2 root 2. The distance from there to there is 2 root 2. What is the type of parallelogram? You can hear all of you saying, it is a square. Now, that's where the problem lies. Give us reasons why you say it's a square. So with the square, we know all sides are equal, but that is not enough. Remember, if we say all sides are equal and we leave it there, remember in a rhombus, all sides are equal. All right? So what is the difference between the two? It is that in this one, you can see all these angles are equals to 90 degrees. Okay? Angles equals to 90 degrees. Each angle equals to 90 degrees. Okay? So that makes it a square. Because in a rhombus, you can see in a rhombus, all sides are equal, but the angles are not equal to 90 degrees. So there's a difference between the two. Okay. Now, determine the equation of the tangent. I'm now going to use that formula. Now, you can then please use the other formula for the gradient, where you're going to find the gradient of the line and the gradient of that line, and then from there you get it. I'm going to use this one now. Going forward, x1 times x, or x times x1 plus y1 times y, is equals to r squared. They say WR. See, the tangent here. You must first check which tangent they're asking. They might have asked this one. Must know. Okay. Then what am I going to do now here? I'm going to substitute by a point, and that point is the easy point, is this point here. The x value is 2 times x. The y value is negative 2 times y. The r squared is 8. Then we're going to have minus 2y equals to negative 2x plus 8. Then I need the value of y, so I can divide throughout by negative 2. So I'll have x, then I'll have, so this is minus 2y, so I'm going to divide by negative 2y. So if I divide by negative 2y, what am I not getting right here? Okay, the gradient is fine. So if I divide by negative 2, negative 2, negative 2. So I'll get y is equals to x, then minus 4. So I can see, why am I saying I'm right? I can see that this is a positive gradient. The gradient is positive, we're increasing, and this point for the y-intercept can be -4. Just speculating, might be. Now, this type of questions are quite easy and we must get them. We'll take 2 minutes break. Okay, welcome back. Now, question 4, we are done with question 4, but then we have this question that comes every year, every paper, it is there, 3 marks, but now you can see now I'm doing different type so that we are able to see how we can get marks on this one. Now with this one, it's quite easy, is the square root of 1 plus minus on the x, square root of 1 is 1, 1 and minus 1. The square root of 16 on the y, it's 4, so it's 4 and minus 4. Please make sure that you write the values if they're not written. Then from there you will get full marks. So this is a slim ellipse. See, it's a vertical ellipse. So in this case, you just indicate the values, and then you'll get your 3 marks. Right. The next question here in the diagram below, O is the center. Always going to be the case like that. You can't find any circle where they say, oh, it's not the center. It must always be the center. I have a point here. Is this correct? -9 and 3. Yes, that's correct. They're telling me now I cannot just speculate that it is a tangent. It must be specified here, unless if they say prove that it's a tangent or show that it is a tangent. In this case, they just say find the equation of the circle. Once we find the equation of the circle, what do I know about the circle? It's x squared plus y squared equals to r squared. You must know this. Formula is there in the formula sheet. So which means, you remember I said you can be given a point to get the equation. So the point is given, it's a -9 squared plus 3 squared equals to r squared. So this is 81 plus 9 equals to r squared. So my r squared is going to be 90. They asked me to get the equation of the circle. So I must come back here and say, therefore, the equation of the circle is y squared plus x squared plus y squared equals to 90. Okay. Obviously, the next question will be determine the equation of the tangent. So the equation of the tangent, see how steep that tangent is. Meaning that if I continue with that line here, that line is going to touch up there. So my y-intercept will be positive. So now, the equation of the tangent, we can still go, I'm just going to interchange my methods because those two methods, they work nicely together. If I interchange my method and say, I'm starting with the gradient of OE is, remember, it's 3 over 9. So y value over x, as long as it's coming from the center. So it's 3 over negative 9, which is negative 1 over 3. What will be the gradient of the tangent? Easy. So the gradient of the tangent, if this gradient here is 1 over 3, negative, the gradient of that will be 3 over 1, positive. So which means that the gradient of the tangent will be 3. Then I can use my formula y minus y1 equals to x into x minus x1. In the meantime, when I'm doing it with this formula, you do it with the x1 times x plus y1 times y equals to r squared. You still get the same answer. Right. So y minus y1, so my y1 is 3. The gradient here, the gradient here. The gradient is 3. The x1 is minus 9, so it will be minus 9. Right? Now I've got y equals to 3 times x is 3x. 3 times negative, negative 9. It's 20 plus 27. Bring over the 3. So my y will be 3x. How do I know that I am correct? How do I know? I know I'm correct because the gradient here is positive. See, the gradient is increasing. How about the 30? I know that that graph, if I move that graph up there, it is going to touch up there at 30. I know I'm correct. If I got a negative 30 there, it means that the graph was supposed to go down here. So you can see that you're correct. Your answers are close to being correct. Okay. Or they are correct. We must make sure that they are correct, actually. Okay, now. In that next question is the ellipse again. Can you see how many ellipse graphs did I draw? Because I'm emphasizing this because this question is always there. So that's why I put that question there. Right. Given that function, express this equation in this form. So as long as it's equals to 1, that is fine. So I'll go here and say, what is this value here? What is this value here? By using the square root. So I'll have x squared over, square root of 9 is 3. I must put a square here. Because 3 squared is 9. Which number here gives us 25? If I take the square root of 25, it's 5. It's 5 squared, and the answer equals to 1. I'm done. That's your 1 mark. Okay. Right. In the next one, obviously they'll say hence sketch the graph. So hence mean whatever you got there is 3 squared. There you got a 5 squared. You go to your graph. On the x, you look for 3. On the y, you look for 5. And then from there, you freehand to draw the graph. And that's your. Don't forget, if the numbers are not there, you just put your numbers there. And there's a 3 and there's a minus 3. Then you get your 3 marks. Simple as that. Straightforward. These graphs are just straightforward. Okay. In this activity, LMN is a tangent is given, passes through 3 and 4. I'm not going to waste a lot of time here because we already know how to then draw the sketches. I mean, to get the equation of the sketches. Now I've got this point here as R, B, and 0. That will be my problem here. That's why here they said determine the equation of the circle. Now the equation of the circle will be x squared plus y squared equals to r squared. Then the only point I have, this one, I don't know what b is, so I cannot use it. Otherwise, I'm going to have an equation of the circle with b squared plus 0 equals to r squared. So I need a point 3, minus 3, and 4. So if I go to my substitution there, x value is minus 3, the y value is 4, the r squared is what I need. So I'll have a 9 plus a 16 equals to r squared. And my r squared is going to be equals to 25. Right? So if I've got r squared is 25, then I'm able to can write down my equation, because they need the equation, x squared plus y squared equals to 25. There's the equation of the circle. From the equation of the circle, I need to get the numerical value of b. But already I know x squared plus y squared equals to 25. I need what b is. I know what is my y. So I can come to this equation here and substitute. Or I know from the center to there, it's a radius. And my radius out of the radius squared will be radius squared equals to 25. My radius is going to be 5. So the distance from 0 to that point here will be 5. So meaning that my x value here will be 5. So I can just write down b will be equals to 5. If I don't want to do it like that, I'll have to substitute the value of x by b, substitute the value of y by 0 equals to 25, and the answer will still come back to 5. You will get b equals to plus minus 5, then obviously you have to choose the positive on the right-hand side of 0. Okay. Now, how do I determine the equation of LMN? Now, LMN is a tangent. Already it is given in the statement that LMN is a tangent. So here they just ask you to get the equation of LMN. Okay, already I know it's a tangent. So I'm going to use the other formula, x times x1 plus y times y1, and I want you to use the formula for the gradient, finding the gradient of that line and the gradient of that line and a point. When I finish this, you must also be done with the other one. Let's see. The M point is given as minus 3 and 4. Substitute. Minus 3 times x plus 4 times x equals to 25 times y equals to 25. So I've got 4y, it's equals to transpose the minus 3x, it becomes positive 3x. 25 is still positive. Divide by y, by 4, we get 3 over 4x plus 25 all over 4. That is the equation in the form y equals to mx plus c. Even if I use the gradient will be 4 over minus 3. The other one will be 3 over 4. So we'll be correct on this. Okay. Right, another trick, ellipse, that they give us. Isn't it that we are used to the 4 and the 16 and the 25 and the 64 and 81 and 1 and all that, which are perfect squares. But once they bring something that is not a perfect square, like 7 is not a perfect square. So now we need to figure out what should we do with it 7, because I'm going to get the square root of 7, which is between 2 and 3. So the square root of 9 is 3, the square root of 4 is 2. So 7 will be between those two numbers. So the first thing that they will ask you is to write down in this form. Why? It is because they want to make sure that when you go and draw your ellipse, you are drawing it with a correct correct x-intercept and correct y-intercept. That's the aim of asking you this question. So I'm going to come here and say x squared over. So what should I write here? The square root of 7 squared. Now remember, if I square a square root, I'll remain with the number inside the square root. So in this case, x squared over square root of 7 squared will give us that number here. Right. With 49, it's quite easy. So I'll say y squared over 7 squared. Well, 7 squared is 49. And that is equals to 1. You see the trick here is just to make sure that you understand that how to write this one is a squared, how to write down is b squared. All right. So with a number which is not a perfect square, then you must put a square root. So that we can have this. So yeah, the trick here was the relationship between 7 and 49. Because square root of 7 is not as the same as 7. Because when you go and draw the sketch, you realize when you draw the sketch that the 7 here and the square root of 7 are far apart. Because the square root of 7, as I say, it is 2 comma. It's just below 3. Right. Let's go to the sketch. In the sketch, draw this. So we say the square root of 7. So I said the square root of 7 is 2 comma. So somewhere there. We don't have to be very accurate. And it's 2 comma something. So we don't have to be accurate with respect to that. I know when you go to your workshops and all that, you'll be requested to be accurate to a certain decimal or so. In this case, I have a 2 here, so I'll just put it just next to 2 because there's a 3 next to it. So I just put my little cross here and my little cross here because of the x squared over square root of 7 all squared. So if it's all squared, it means that it can either be negative or positive. Plus y squared all over 16. Sorry, all over 49. 49. And that 49, we said it's 7 squared. Okay. So if it's 7 squared, we then go and say, okay, I have a 7 somewhere here. I'll have a 7 somewhere there. Right? Then from there, I put this as a 7. This I put as square root of 7. This I put as negative square root of 7. And this is 7. Oh, sorry, negative 7. Then I can go and draw my ellipse. Every time I draw an ellipse, it must look like an ellipse. Okay, must look at like that rugby ball that you have seen in that question. It cannot look like a, where you write you draw a four-sided figure. Cannot look like that. That is not acceptable. If it looks like an ellipse, you get your full marks because your scale is correct. Once your scale is correct, then you get full marks. If I come here and put a 7 there and a 7, negative 7 there and a 7 there, and I don't know what I'm going to put, 49, then that will look like an ellipse. It will be an ellipse, but it will not be at the right place where the square root, the 7 and the minus 7 are supposed to be in the right place. Sometimes we see you draw the correct ellipse, but the x-intercept and the y-intercepts are incorrect, and that's where you lose marks. You just get 1 out of 3. So for you to get 3 out of 3, the correct x values, the correct y values, and the correct shape. Obviously, if you've got the correct x values and the correct y values, the shape will be 100%. Okay. In the next activity, I see we have a bit of a challenge here where we need to justify the answers. It says in the diagram, O is the center, which is always going to be the case. And then the equation of the line PQ. You see the line PQ, you are not told that this is a tangent. It is not. It cannot be a tangent if you're not told. Unless you have to justify your answer of saying that is a tangent. That equation is given as y equals to 3 over 4, which is the gradient, and minus 6. It says it interacts at this point at 2 and minus 3. Determine the equation of the circle. So the equation of the circle, obviously this point is on the circle. So can determine the equation of the circle. The formula is x squared plus y squared equals to r squared. Then I substitute 2 squared plus negative 3 squared equals to r squared. So my r squared will be 4 plus 9, which is 13. So the equation of my circle will be x squared plus y squared equals to 13. It is not the square root of 13 because it is still r squared here, and here it's r squared. Unless if you are asked to get the radius, all right? Now they ask you, is PQ a tangent? Is this line a tangent? And in this type of question, you cannot just say yes or no, because we want you to justify your answer. Justifying your answer doesn't mean we have to give us a paragraph that you have to prove it mathematically so, and it's easier to do that because I know that if it is a tangent, the gradient of this line times the gradient of that tangent must give us -1. If we multiply them together, that angle must be 90 degrees. So let's check if it is. So how do I check? First, I must get the gradient of OP. The gradient of OP, this is 0, 0. It will be 0 minus 3 over the 0 minus 2. So which is 3 over -2. If I'm not mistaken. It's 3 over -2. So the gradient of that is 3 over -2. So the value of the y value there is -3. So we said 0 minus -3, and then from there it will be that. So the gradient of that is a decreasing function. Right. Now we're done with that. Let's get the gradient of PQ. What is the coordinates of P here? Right. I don't know. But what do I know? I know that this line here is the equation of that line. Then the point here, the value here is the gradient. So meaning that the gradient of PQ, I know it. I'm given 3 over 4. I can still go and get the coordinates of that point by substituting the y value by 0 and then blah, blah, blah. But why do I have to do that? Because the equation is given, the gradient is given. Right. Now, let me try this and say the gradient of OP times the gradient of PQ. This must give me -1. If it doesn't give me -1, therefore PQ, it's not a tangent. Let's see. What is the gradient of OP? It's -3 over 2. The gradient of PQ is 3 over 4. If I multiply this, I'm going to get -9 over 8, which cannot be equals to -1, which is not equals to -1. Therefore, what do I write? Therefore, PQ is not a tangent to circle at P. It cannot be a tangent to a circle at P. Reason being, the two gradients multiplied together that don't give us -1. We know that from the radius to that if it's a tangent, it must give us negative. So that's how I justify my answer. So I'll say, no, it's not a tangent to that circle. Okay, right, now let's get to the next question. In the next question, I'm drawing, I think, ellipse number 8 or 9. Same principle, but in this case, the square root of 20, can you see there? Square root of 20. Square root of 9 is fine, so the y values are fine. It's going to be 3 and negative 3. But now the x values, it's square root of 20. What is square root of 20? The square root of 20, it is between, remember in grade 10, you're doing this sets, between which integers does this set lie? So in other words, square root of 20, between which two integers does square root of 20 lie? It will be between square root of 25 and square root of 6. Square root of 25 is 5, square root of 16, 16, square root of 16 is 4. So it will lie between 4 and 5. So just go here and see, can you see work that you have done previously? You still need to know it because now we need to use this. It will be between 4 and 5. Any place between 4 and 5 there, it will be closer to 4 than to 5. So in this case, I must also go there and put it there. And what do I put there? Square root of 20. Do not try and put decimals in there. Just put it as it is, negative square root of 20. And there it's a 3, there it's a negative 3. So therefore, I can just draw my ellipse, make it a point that it joins all the points, and then we have a horizontal ellipse because the value of x is bigger than the value of y. So that's why we have a horizontal one. If the value of x is smaller than the value of y, then we have a vertical ellipse. All right. Now here we do not have a circle. We have a semicircle which is below the x-axis. So if I say determine the equation of a semicircle, so in this case here it is below the x-axis. But I know that the equation of the circle is x squared plus y squared equals to r squared. I can start here, not a problem, so that I can find the radius. Now, the value of x, I have 1, 2, 3, 4 coordinates, A, B, C, Q coordinates. I have 4 of them. In the 4 coordinates, I can use any of those. Why? Because they are all on the circle, on the semicircle. So for you now, I'm going to use the simplest one. I want to use this one. I don't like negative numbers and square roots and all that. I don't like that. I'm going to use the simpler one, and then you can go and use those ones. Or maybe let me just be brave and use the Q coordinates. Let me just be brave for now only. You can use the simpler one. It's fine. Let me just be brave for once. Now, at Q, we have got x and y, so I'm going to have my x value is going to be 2 squared. My y value is going to be negative 2 root 3, all squared equals to r squared. Then I'm going to have a 4 plus 2 squared is 4, 4 times 3 is 12, so I'm going to have a 12. And then my r squared is going to be 16. So you guys, you have used this one and make sure that you still get 16. Then my equation of a full circle is x squared plus y squared equals to r squared. Or 16 for this one. In this case, 16. But because my equation is below the x-axis, listen carefully here. Because it is below the x-axis. The other way of writing the equation of the circle is y equals to plus or minus the square root of r squared minus x squared. That is one other way of writing the equation of the circle, of a full circle. If it's a semicircle and it is below the x-axis, my equation will be y equals to minus the square root of r squared minus x squared. If it's above the circle, if it was above the circle, so it was going to be y equals to plus the square root of r squared minus x squared. So I just transpose the x squared and then from there take the square roots on both sides. Then in this case, I know what r squared is. My r squared is 16. So the equation will be y equals to negative square root of, remember I'm putting r squared, I'm not putting r. 16 minus x squared with a minus. And that is my equation. If you leave it here, you're telling us that it is the equation of the straight of the full circle. So you need to know this is very, very, very important. You must know how to get this so that then you know the equation of the circle is like that. Okay. Then they say calculate the gradient of OQ. The gradient of OQ. Now they're guiding you. I love the questions where they guide you. I know the next question will be determine the equation of the tangent. Already you know the equation of the radius. I mean the gradient of the radius. So what is the gradient of that radius? It's going to be m equals to 0 minus 3. Go ahead, no, 7. The gradient of that one should be, don't know where I'm putting the 3 because I have this. So it is going to be 0 minus 2 root 3. But the 2 root 3 is a negative, so that should be a positive. Because I'm taking a 0 from here, so it's 0 minus that number, which is a negative number. Negative times negative is positive, divided by, what is the x value? So if I started with a 0 here, I must also start with a 0 for the x. It's 0 minus 2. So the gradient of that line here, it's going to be, the gradient of OQ, it's going to be 2 root 3 divided by minus 2, which is going to give us negative root 3. That is the gradient of that line. Now it says hence. Hence means use the gradient you got there to do that. So if I use the x times x1 plus y multiplied by y1, I will not be using the word hence. So I'm going to go the long route. So I know the gradient of OQ. The gradient of OQ is negative root 3. So what will be the gradient of the other line? So the gradient of the other line is going to be, which is the tangent. The gradient of the tangent is going to be, remember this negative square root of 3 over 1. So this one will be 1 over 3, which is a positive value. Then I'm going to use y minus y1 equals to m into x minus x1. Then I use my y1. Remember now I'm using this point here, right? So this is going to be plus root 3. The gradient is 1 over root 3. The x1 is minus 2. So I'm going to have y is equals to 1 over root 3 x, and then that will be minus 2 over root 3 minus 2 root 3. Okay. So because that one should be multiplied by that, so I get 2 over root 3, and then I transpose this one that side, then I'll get this. And then from there, I can just work that one out. This multiplied by that will give us 2 times that is 6. So it will be negative 8. So I'll have, right? So I'll have 2 over 3 minus, then minus 2 root 3 over 1. So I can just multiply the root 3 multiplied by this. So I'll get 2 multiplied by 3 minus 2 there. So this is a 6, and that, so I've got a minus 8 there. So my answer will be y equals to 1 over 3x minus 8. Am I right? So therefore, I know if I move this line here, that line there will go through minus 8. So I might be right. Okay. And the gradient is positive. This line is a positive gradient. So we've got a plus, 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 plus. And then you can check with me if that gradient is correct. Remember, it doesn't pass through these points, no? It doesn't pass through this point. So you cannot use those points. You must use that point. Because this is the only point that tangent is going to pass through. Okay, same applies here. This one was an easy one, square root of 25, square root of 16. And the x is 5. On my y, it's 4. Join the points. Have your ellipse done. So in this case, sketch the graph clearly indicating that. Now, this question is a very important question also. Determine the length of the measure axis. So the measure axis is the longest one here. See, if it's a horizontal one, remember, if it's a horizontal, it means that the measure axis will be the x in this case, which is the distance from here to there. You can't take minus 5 and add it to 5, you get 0. The length, we're taking the length here, so the length of the measure axis will be 10 units. Because it's 5 units here, it's 5, distance of 5 and distance of 5, so there will be 10 units. But in this question, easy, straightforward question here. 0, 0 is the center, line CD is the tangent, so CD is the tangent. I have parallel lines, maybe I must use them, I don't know. A is the point given there, x and y intercept of the tangent CD respectively. Coordinates of B, see this line here is parallel to that. So which means that that line there being parallel to that, and on the circle for that matter, the coordinates of B there will be these two coordinates, as this will be the symmetry, because the distance there and the distance there will be the same. So the distance there and the distance there will be the same. So this point coordinate here, B, will be the same coordinate there. We just change the sign of the x. The x should be positive. Y will still remain positive, so it will be 4 and 3. Right. The gradient of OA, remember as I said, the gradient of OA is nothing else. It's a simple thing there. You start with the y value. Remember, gradient is change in y over change in x. If it's from the center, you just take the y value and the x value, you put them together. So in other words, you put the one on top, start with the y, and the other one is a negative. That's the gradient of that. Or you can go the long route of saying 0 minus 3 over 0 minus into minus 4. And then from there, it still give you negative 3 over 4, which is the same thing here. The equation of the tangent, if I use x times x1 plus y times y1, it's equals to r squared. But before I get this, the r squared will be quite easy. R squared will be negative 4 squared plus 3 squared, which will give us 25. So I'm going to go to this value. It's minus 4x plus 3 times y equals to 25. 3y equals to 4x plus 25. Then my y will be 4 over 3x plus 25 over 3. So the equation of the circle will be in that form. Now the last question says D. Isn't it that I know the equation of this line here, which is y equals to 4 over 3x plus 25. Now for me to get the coordinates of D, I already know that the y value is 0 at that point. So I'm going to put a 0 on the x, on the y, sorry, that's 25 over 3, so that I can solve for x. My x must be negative, otherwise then I am wrong. Multiply throughout by 3, I'll get 4x plus 25 equals to 0. Then I'll get 4x equals to negative 25. X will be equals to negative 25 over 4. Leave the answer in the fraction form. So this answer there will be minus 25 over 4. That is my x-intercept at point D. So I'll write D is negative 25 over 4 and it's 0 because the y value at that point is 0. Thank you so much, and please keep on practicing. We'll get these things right. Let's keep on practicing. We are writing next week on Friday. So let's practice and practice and practice. And analytical geometry is one of the easiest topics because the questions that comes there, you've got formulae, you've got about 8 formulae that you can use in analytical geometry, and you can get full marks in analytical geometry. Thank you so much.